linear combination of vectors. Now a vector x which can be expressed in the form x is equal to k1 x1 plus k2 x2 and so on to kr xr is said to be a linear combination of the set of vectors x1 x2 x3 and so on up to xr, where k1 k2 and so on up to kr are scalars. Okay, so if a set of vectors is linearly dependent, then at least one member of the set can be expressed as a linear combination of the remaining vectors, which basically means that if it can't be expressed as a linear combination, what can't be expressed? If one of the vectors can't be expressed as a linear combination of the remaining vectors, then the vectors are linearly independent. And very importantly, the span of a set of vectors is the set of all linear combinations. Okay, now based on this, let's look at some theorems. The set x1, x2 and so on up to xm of n vectors is a linearly dependent set over a field f if at least one of the vectors is the zero vector. Remember, in the previous session we have seen that zero vector always belongs to the linear dependent set. Okay, so let's see. Let x1 equal to 0 vector. That means k1 x1 is equal to 0 for any k1 not equal to 0 in f, and 0 xi is equal to 0, which means basically k2, k3 and so on up to km, they are all equal to 0. So what does this mean? It means that k1 x1 plus 0 x2 plus 0 x3 up to 0 xm equal to 0. So basically these we don't need to write at all. So we end up with k1 x1 is equal to 0. So by definition, x1 x2 and so on up to xm are linearly dependent over f. That is one theorem. Now the second theorem is, did I write theorem here? Yes. Okay, so here if the n vectors x1, x2 and so on up to xm are linearly independent over f, then none of them can be the zero vector. So let's say, let x1, x2, x3 up to xm, let them be linearly independent. If one of the vectors, let's say x1, is equal to 0 vector, then what that means is k1 x1 plus 0 x2 plus 0 x3 and so on up to 0 xm equal to 0 for any k1 not equal to 0, which basically implies, remember, this can be written as k1 x1 is equal to 0. So basically this implies that x1, x2, x3 are linearly dependent, which is a contradiction, because here we said These are linearly independent. By making one of them as 0, what happens? We arrive at the conclusion that they are linearly dependent. So since there is a contradiction, we arrive at the fact that for a linearly independent set of vectors, none of them can be the 0 vector. Now let's look at the next theorem. The set X of one vector X is linearly independent if and only if X is equal to 0 vector. Now to prove this, let's see, let's say X is not equal to 0, right? And we know the equation is Kx is equal to 0. Now here X is not equal to 0. So which means if it has to be equal to 0, it means that K has to be equal to 0, right? So therefore, by definition, the vector is linearly independent. Now let's look at it the other way around. If X is linearly independent, then by definition, X is not equal to K. Another very important theorem, if the set x1, x2, so on up to xm of n vectors is linearly independent over F, then a non-empty subset of this set is also linearly independent. Okay, so if you have a set of vectors, if they are linearly independent, then you take a subset of this. That subset will also be linearly independent. Okay, so let x1, x2 and so on up to xp be a subset where p is between 1 and m, right? If we go beyond xp dot 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 xm, so p will be between 1 and m, implies that k1 x1 plus k2 x2 and so on up to kp xp is equal to 0, or we can write it as k1 x1 plus k2 x2 plus kp xp plus dot 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 km xm equal to 0. Now since x1 x2 and so on up to xm is linearly independent, we can write this, which implies that k1 equal to 0, k2 is equal to 0 and so on, including kp equal to 0, including km equal to 0. So which means what? If we take only up to k1, kp xp, k2 x2 and so on, kp xp, this would also be linearly independent. Why? Because k1 equal to k2 equal to kp equal to 0. So therefore, a subset of a linearly independent set is a linearly independent set of vectors. That's it for now. Bye.